Saxon's Trig, lesson 95, is advanced complex roots. It's on page 551. I feel like we have actually done these before, but if we have not, it is a combination of things that you already know. So in example 1, it says, find the 4 fourth roots of 6 plus 4i. So ultimately, we're looking for the 4 fourth roots of this. And as we learned before, we can't do this unless it is in its cis format. So we need to start with a graph of 6 over 4 up and basically connect a triangle. So this is 6, this is 4. Pythagorean theorem will then give us the hypotenuse. So 16 plus 36, 52, square root of 52, which I'm going to go ahead and put in decimal at 7.21. So square root of 52 is the 7.21, just so you know where that came from. All right, we also need the degree in here, which I don't know. Maybe this is the new part that they didn't do. Yeah, probably. Okay, so again, I would not do the decimal number if possible. I would stick with the original numbers. So that means the opposite and the adjacent. So that would be the word tangent. So tangent of theta, and I'll call that theta, is going to be TOA, opposite of 4, adjacent of 6. You could reduce that down to 2/3. Either way, 4 divided by 6 or 2 divided by 3. Second inverse or shift, however your calculator does it, to spit out the degree for you. And you should get that, theta is 33.69. Now let's write it in its cis format. So it is 7.21 cis, 33.69 degrees. And we're going to now do the 4th root of that. That tells me I have 4 answers. So the 4th root of 7.21, again, that's x to the y to the x with the root. You're looking for that kind of button on your calculator. It could be embedded in a hidden menu. But when you figure out how to make it do that, you should get 1.64. So I know that's going to be for all 4 of the answers with the cis. And then we need to do our 33.69 divided by the 4 to get the first answer of 8.42. Then how do I establish the pattern to get the rest of them? We take 360, we divide it by whatever the root was, 4 in this case, so that's adding 90 each time. So this one is 98.42. Should be 188.42. Oh, forgot my degrees. And then 188 plus 90 is 278.42 degrees. And there are my 4 answers. Example 2 says find the 5 fifth roots of -17 minus 14i, and it wants the 5 fifth roots of that. So again, it needs to be in cis form. So we're going to go -17, -14. So that's in quadrant 3, -17, -14. Pythagorean theorem, 17 squared plus 14 squared, square root that answer. You should get 22.02. Now we need the theta. So again, I wouldn't use the decimal. I would use the 14 and the 17. So again, tangent. Tangents of theta, opposite 14 over 17. Again, I don't care about the signs because I'm going to get the degree and then I'm going to make the adjustment myself. So 14 divided by 17, inverse shift or second tangent, whatever it is, your theta should become 39.47 degrees. But when I go to write it in my cis format, so it's going to be over here, 22.02 cis, again, because it's in the 3rd quadrant, I'm going to do 180 plus the extra 39.47, making it 219.47 0.47 degrees. Now I want to do the fifth root of that. So 22.02, take the fifth root of, and you should get, I'm looking for the small number, 1.86. How many times are you going to have that? 5 times, with a cis with each one of them. And then the degree was 219.47 divided by 5. So our first one, 43.89 degrees. Establish the pattern, 360 divided by the 5. So every time we are adding, just a second, I'm only finding the 43.89. Oh, bummer, I don't think it actually gave me that number. Okay, so 360 divided by 5, 730, so 72 degrees, goodness. 72 plus 43 here, so my 0.89 is going to exist every time. 5, so 115.89, I want to make sure, yeah, that is their next answer. Okay, then add 72 again. Every time I'm going to have that 0.89, and then 72 plus 5, 6, 7, 187, checking as I go, plus another 72, so 9, 15, 259.89, yep, add another 72, 13, 3, yes, 331.89, and there are all of those answers, all 5 of them, okay. Oh, and there are no other examples in this lesson.